Let's take a look now at example 5, the last example for this section. The data in the table below represents the income distribution of households in the U.S. back from 2009. Now what you'll see here is this is actually one big table that I kind of had to chop up and lay side by side. Notice that I have 5 different annual incomes over here at the left, and technically this portion should actually just be able to kind of be copied and pasted right down here to continue the table. So I have income levels, more income levels, and then the number of households, measured in thousands, that actually meet those descriptions. In total, there were 117,450 households surveyed. Well, if I assume that I'm going to grab a household at random here, I could ask some different questions, like, what's the probability that the household earns $200,000 or more? Okay. Well, let me just write that out. I want the probability of earning $200,000 or more. Well, this is super simple. I can go through and figure out if this is randomly selected, then I know everything's got an equal chance of being picked. So I just need to know how many households actually made this much money. Well, that's easy. There's a whole group for that. So there's just 4,506 individuals that meet that description. If I go to a calculator and write this out, I think I end up with something like 0.0383. Great. Super simple. Not even a complicated question. No fancy formula required. Nothing at all. Well, what about if I was to do less than 200,000? I want the probability that a household earns less than 200,000. Well, let's see. Which groups would they be able to fall in? Oh boy. You might be able to start to see the problem already. Doesn't the first category have houses that make less than 200,000? I mean, absolutely, right? But also the next one? Also the next one, and the next one, and the next one. And a lot of these, almost every single one of them, is going to have this. So would we be happy if we got a household in the first group? Would that make, finding a house that would earn less than $200,000 happen? Well, definitely, right? I mean, we definitely would have found a household like that then. But I would be happy if that household that I found came in the first group, or in the second group, or in the third, or in the fourth, or in the fifth, or in the sixth, or in the seventh, or in the eighth, or in the ninth. Can you tell what key word I'm using over and over again? It's or. Oh my gosh, well you could see that ultimately what you would end up having to do is just say, you're going to have to add up how many total people there are in each one of the blue categories. Well, even though that's not that hard, right, you could bust out a calculator and quickly start adding up the number of households in each of these categories. Wouldn't it be a lot easier to tackle this by using a complement? Notice that there are 9 categories here in this list that we do want, but there is only one category in here that we don't want. This is where complements can save us an immense amount of time. I can get all of the blue numbers by just saying I'm going to take 100% total, and I'm going to subtract off the probability of earning $200,000 or more. That is, I'm kind of chopping off of the total probability the only portion that I'm not interested in. Now, fortunately for us, we already kind of computed this in the last step, right? That's like 1 minus 0.0383. And so it's not surprising we could easily arrive at a final answer, which I think would be 0.9617. I can get there really, really quickly. But this is the power of complements, is that instead of having to add up all the blue, I can just subtract maybe one quick thing. Take a look here at part C. We have the same idea. Here I want the probability of getting a household that earns at least $10,000. Okay, well if I go back up above and I start to think about all of the categories that I want, which are the categories that are going to be earning at least 10,000? So 10,000 is the least amount they can be earning. Well, here's 10,000, and well, would you look at this? All of these different categories are earning 10,000 or more. Well, that's again 9 different categories I have to go add up. However, there's only one category that I don't want. So a complement can save me a lot of time by writing something like the following. How about we take 100% and we chop off the only probability that we don't want, which would be the probability that we find a household that earns less than $10,000. Well, notice we can crunch that out pretty quickly. I know, again, total, there are 117,540 total households. It was the case that 8,570 of them fall into that first category. And so if I go to a calculator and I actually type this out, my 1 minus this particular fraction, and go ahead, you actually go to your calculator, type it in, and double check me, but I think I end up with the total value of 0.9271. So this can save a lot of time, a lot of time. Now, here, it may not seem like it saves that much time, right? Because like, how hard is it to add 9 numbers together on your calculator? But can you imagine if instead of 10 different categories for annual income, what if I had 10,000 different categories? Yeah, you're probably not going to want to add up, like 9,000 something different categories for a problem. That's just not time efficient. So complements can be great because they can allow you to say, hey, instead of computing all of these things, why not compute the stuff you don't want and take it off of the grand total? Now notice back in part A, we could have done the same thing. It just would have been a lot more tedious. In part A, we were only interested in this group, which meant that all of our other groups were technically X'd out. So we could have found that blue by finding instead all the stuff we didn't want and subtracted from 100% as well. But of course, in that instance, the complement would seem like a lot more work. So it's not that a complement always is going to provide you with the shorter approach, but that it sometimes might. And so it's worth considering when the approach that we have at hand, like we did at B and C, seem to have a lot of work involved in them. We'll see more about complements and how they get used in future sections as well.